what is blockchain technology? Now, before we get to the defining what blockchain is, in the previous lecture, we introduced the term node, right? So it's key that we first of all understand the term node because we'll be coming across this term from time to time across the entire course. So what is a node? Now, a node is simply a computer connected to the distributed decentralized network. Pretty much in tech senses, a node is just a computer connected to a particular network. This could be your typical computer like the one you're using right now, or your phone, or even a modem. Simply anything connected to a network is called a node. But for blockchain sense, let's refer to a node as a computer connected to the distributed decentralized network, which in most cases will be the blockchain, or the blockchain protocol we're talking about. However, note that in distributed decentralized network, each and every node stores a copy of data or information or transactional records, as we discussed in the previous lecture. Now, let's get to defining what blockchain is. Now, there's no definitive way to define blockchain. There's no particular way to define blockchain, but I'll try describe it in a line or two, something that would be simple and understandable to people who are new to the entire concept. So what is blockchain? Blockchain is simply, in the basic sense, a distributed decentralized database. Yes, blockchain is just a database, but it's a special type of database because it's distributed decentralized in the first place. Now, there's other stuff to add on top of blockchains. Blockchain is a distributed decentralized database that's governed by a protocol that allows for peer-to-peer transactions and institutes network-wide consensus. Now, out of this definition, there's three things we can take away from the short definition. One, it's a distributed decentralized database. Yes, it's just a database. Two, it allows for peer-to-peer transaction. Given that each and every single person stores a record of transactions, it means there's no point of a central authority, so we can have peer-to-peer transactions. And three, it has a protocol that institutes network-wide consensus. We're all storing a record, transactional records, information, or data, but the protocol governing the blockchain makes sure that data stored in computer A is similar to data stored in computer B, it's similar to data stored in computer C. So it doesn't matter how many people are storing records, but each and every single person is storing records that kind of the same. There's consensus within the network. There's not conflicting. There's no conflicting information, data, or transactional records. And those are the three key attributes of blockchain that we'll be jumping onto, but the basic sense, it's just a distributed decentralized database. Now, let's jump to this individual aspects. Let's jump to all these aspects individually. Now, before we get to all those aspects, there's another term we all need to know. Now, blockchains are mostly used for transactional use cases. And whenever we talk about transactional use cases, people are used to the term ledger. Now, let's define what a ledger is, because this is also another term that you'll come across a lot in this entire course. So a ledger is simply a written or computerized record of all the transactions a business has completed. So in simpler terms, instead of calling blockchain a database, blockchain is also referred to as a distributed ledger technology. So yes, it's a distributed database. A ledger is just like a database pretty much. So we can just call blockchain a distributed ledger technology. But ledger happens to be the preferred term whenever we're talking about transactions and transactional records. And that's why we'll be talking a lot about ledgers rather than databases, or rather we'll be using the term ledger more than databases across this entire course. Awesome. Now let's get to those individual aspects. And we'll first of all start with blockchain as a peer-to-peer network. Let's start with the first aspect, blockchain as a peer-to-peer network. In the previous lecture, we introduced centralized databases, and we stated that in centralized databases, if Alexa wanted to send money to Bill, they'd have to use a central database, or rather a central authority who owns the central database. And in financial cases, this is usually a bank. However, with blockchain, there's no point of central authority because it's distributed in the first place. Therefore, you can have a peer-to-peer direct transaction, as you can see with the arrow linking Alexa straight up to Bill to your left. So blockchains allow for peer-to-peer transactions. Now, Bitcoin is an example of a blockchain applications where transactions occur between two different parties without the need for a third party, a bank. Blockchain is a disintermediator. It kills the whole essence of a third party or an intermediary in any sort of transaction. Therefore, as a peer-to-peer network, digital assets can be transferred from node to node directly, Alexa's node to Bill's node directly, without the need for that central authority. And that's the first aspect of blockchain. Now let's get to the second aspect, which is something you're already familiar with. As discussed earlier, under distributed decentralized database, and we all know that blockchain is a distributed database in the first place. There is no particular storage point, and information is stored in each and every node in blockchains. Yes, when you talk about blockchain networks, you don't only have the bank storing transactional records, but Alexa, Bill, and all participating networks store the same transactional records each and every single time there's a transaction. And that's the whole aspect of blockchain being a distributed decentralized ledger. Keep in mind that decentralization is the basis of blockchain technology, in that a decentralized ledger system will replace the central database, which we see in centralized networks like banking networks. So in Bitcoin, instead of having a central database like we see in banks, this decentralized ledger system becomes the record-keeping system, pretty much. Now let's get to the third aspect, and before we get to the third aspect, another key term we all need to know, and that's the term protocol, for those of us who are new to technological stuff. Now, a protocol is simply a set of conventions governing the treatment and especially the formatting of data in an electronic communication system. Now, that's the Merriam-Webster definition, and it sounds pretty complex, but let's simplify this for you in blockchain terms. A protocol is simply coded rules and regulations governing blockchain networks. So these are just rules and regulations that are coded, written down in code, that govern how the network operates, how we transact in a particular network or blockchain network in this particular case. Now, let's get to this third aspect, which stated that blockchain has consensus that's governed by coded protocols. Now, let's look at it. In centralized networks where there's a single central authority to update and manage transactions and records, there's really no point of more of a consensus protocol. You have the rules and regulations, so all the centralized authority does all the dog work that comes with making sure that you update, you manage transactions, and you keep all different records. But when you're dealing with so many nodes in a particular network and all of them need to have some sort of consensus, blockchains have this sort of protocols that govern that entire process, that make sure that we all agree in terms of the information and transactional records we are storing. Now, keep in mind that in blockchain networks, no node has power over any other node. Therefore, coded protocols are used to enforce this network-wide consensus without necessarily giving authority to any node or a set of nodes. Now, let's look at the major aspects that these protocols govern. First, the protocols determine the utility of a particular blockchain network. They determine whether a blockchain will be used for to transact item X or a different thing. So they determine the utility of a particular blockchain. Now let's look at example. The Bitcoin protocol allows for the Bitcoin network to be used for monetary transaction. But we do have different blockchains. Blockchain is not just for monetary transaction. For instance, trading of digital storage. And we have the SIA protocol that has SIA coin. Let's call it SIA coin, that allows the network to allow for trading of digital storage, whereby I can share my cloud storage with someone else. Cloud storage is still a digital asset, and the protocol determines how, or rather allows for us to trade cloud storage. Lastly, we have even more complex protocols that are not just used to transact, but even allow you to build smart contracts. For instance, Ethereum is a protocol that creates a platform for building smart contracts. And we'll get deeper into the topic of smart contracts and decentralized application later on in this course. But pretty much, first, the protocol determines the utility of a particular blockchain. Now, the second aspect, or rather the second aspect that a protocol governs that's very, very key to blockchains is protocols also determine how transactions are verified and added to the public ledger. Now, this is the whole aspect of consensus. Protocols govern the addition and modification of transactions in a blockchain, and I know we've all heard of block mining. The whole point of protocol determining, or rather governing, the verification and validation process of transactions is to make sure that transactions added onto this public ledger, or rather this distributed database, are similar all across. Therefore, we have a blockchain protocol that allows for a verification process, and once a transaction is verified, the record is added in each and every single node in the network. Now, to make sure that a malicious node does not act against consensus, this protocol also makes the entire database immutable. And immutability means you cannot delete or alter records. So this protocol is pretty much the pillar of security throughout the entire blockchain. And we always talk about blockchains being immutable, and we'll talk about why they're immutable, what aspect of this protocol makes them immutable. And it's the mere fact that these protocols are coded to make sure that transactions cannot be deleted or altered once they're verified and added onto the network, and to make sure that each and every single node is saving the similar transactional records or information. Now, those are the three aspects of blockchains. We talked about it being a distributed decentralized database. We talked about it allowing for peer-to-peer transactions. And we talked about the protocol that governs the utility of a particular blockchain and goes ahead to determine how transactions are added, verified, to make sure that whatever we have across the network is pure consensus and records are not different from one node to another. So how exactly does blockchain technology work? Now let's look deeper into this. Now, how are transactions made, verified, and added onto the blockchain? This is the entire process that the protocol governs. First of all, let's think of Alexa and Bill, the same people we had. Alexa requests a transaction. For instance, Alexa wants to send 1 Bitcoin to Bill. After Alexa requesting that transaction, this request is broadcast to all nodes across the blockchain network. Then this transaction is verified through a process called mining, which is something we'll discuss in further topics once we get into module 3 and 4, and we'll get deeper into the mining process, the verification of transactions. Once a transaction is verified transactions are combined with other group of transactions and added onto a block, right? So a block is pretty much a group of transactions grouped together. This block, or rather let's call it a mined block, is then broadcast and added onto the blockchain, where it is unalterable. You cannot delete it, you can't alter it. It is totally immutable. And we'll talk about blockchain immutability more when we get to module 3, when we cover cryptography, crypto economics, and module 4, where we look at the mining process as well. And then the transaction is complete and Bill receives the Bitcoin from Alexa. And this is simply how blockchains work. And definitely blockchain is a database, but this is the whole verification process and pretty much whatever the protocols govern. Now we have a huge disclaimer. As much as we use Bitcoin and monetary transactions to explain how blockchains work, blockchains are used to transact any assets of value and are not only applicable in finance. That's a key aspect. But don't worry, we'll explore different use cases of blockchain technology as we delve deeper into different blockchain protocols and industry applications later on in the course. Once we expose you deeply to the technicalities of blockchain and you get to understand all aspects of blockchain, we'll start exploring the different applications and the different assets that could be transacted on blockchains in the first place. So you might be asking, whatever you've talked about is pretty much blockchain being a database, and if it's any special database, it's just a distributed, decentralized database. But there is a distinguishing factor of blockchain technology that makes it more than just a distributed, decentralized database. Why is blockchain so different from these traditional decentralized networks? And this comes down to the protocol. The distinguishing factor of blockchain comes down to the protocol. As much as blockchain is just a distributed decentralized database, blockchain combines different technologies, specifically cryptography, and creates network incentives to enhance trust and disincentivize any players from taking down the network. We talked about the protocol coming in and ensuring security and making sure transactions and cannot be deleted and cannot be altered. And this aspect of the protocol that allows for this is something we call crypto economics. And this is something we'll explore deeper as we get to the technicalities of blockchain technology in module 3. But let's just define what crypto economics is for a start. Crypto economics is the use of economics, that's just giving people incentives, right? And cryptography, that's pretty much encryption to design a secure system or network with predefined desired properties. It's pretty much cryptography, which is the security bit where we add up encryptions, and then economics, where we give incentives for people who do the right thing, and we punish the people who don't do the right thing, right? And when you add this, it gives you crypto economics. So incentivize people to do the right thing, and as well have that cryptography framework for security. And this is a huge aspect of the blockchain protocol that makes it very unique, very secure, and very different from just your typical distributed decentralized database.